What if you had to find something that's totally invisible? Sounds like something out of a sci-fi movie, right? But here's the thing. In the world of physics, nothing is ever truly invisible. Every single object, and I mean every object, is actually kind of loud. It's always giving off these little signatures, these tiny traces that it exists. The real trick, though, is that these signatures are often completely beyond what our human senses can pick up. So, that's the big question, isn't it? How do you find a target that's doing its best to hide in complete silence and total darkness? Well, our eyes and ears can only do so much. In this explainer, we're going to dive into the amazing tech that exploits these hidden but very, very real signatures that every target leaves behind. Okay, so this all comes down to a really simple idea. Targets are always detected by their unique characteristics. But when you're dealing with darkness or a fog or just huge distances, our senses, they just don't cut it. And that's exactly where technology steps in to save the day. To put it another way, we use technology to basically give ourselves superpowers. It lets us see and hear things that are physically there but totally invisible to us. And for the most part, we can sort these methods into three main categories. First up, and this is the big one, we have electromagnetic energy. We're talking about things like light or radio waves. Then you've got mechanical waves, which is just a fancy term for sounds and vibrations. And finally, there are all these other little effects, like chemical traces or even smells. All right, let's start with the one you'll see the most, exploiting the electromagnetic or EM spectrum. This is, without a doubt, the most common way we find things that don't want to be found. And right away, we have to make a really important distinction. See, sometimes EM energy is sent out on purpose, right? Think of a radio station broadcasting a signal. But way more often, it's something totally unavoidable. It's just a natural byproduct of existing, like the heat pouring off a running engine. You can't stop it. And think about this for a second. Any object that has a temperature above absolute zero, which is, let's be honest, pretty much everything, is constantly radiating heat. And most of that unavoidable heat energy, it's given off in a very specific slice of the spectrum called the far infrared. It is a constant, undeniable signature that everything gives off all the time. So how do you see this invisible heat? Well, we use these incredible systems like thermal imaging, or TI, and infrared line search. What they do is take that unavoidable heat signature and translate it into a picture we can actually see. It literally allows us to see in complete and total darkness. But hey, seeing heat and light isn't the whole story. The EM spectrum is incredibly powerful, for sure, but it's not the only tool we have. We can also find targets by, believe it or not, listening to the ground and even smelling the air. So when we talk about mechanical waves, we're really talking about movement and sound. When a big, heavy truck drives by, it creates tiny vibrations in the ground. We call those seismic waves. And we have sensors that can pick those up from far away. In the same way, we can use super specialized microphones to listen for the unique acoustic sound of, say, helicopter blades and figure out exactly where it's coming from. And last but not least, targets leave behind chemical clues. This could be the super faint scent of explosives or other specific materials. We can tap into this using the amazing nose of a trained dog or with highly sensitive electronic sensors that are built to detect specific chemical particles floating around in the air. Okay, that's a lot of theory. Let's put it all together and see how it works in the real world. I want you to picture a tank. It's hiding perfectly still in a forest, late at night. The engine is off. It's trying to be as quiet and as invisible as possible. This is where it all clicks into place. So first up, a soldier looking through binoculars, he sees nothing. The tank is invisible. But pull out a thermal imager and bam, it instantly sees the heat that's still radiating from the tank's metal body against the cool trees. That's its unavoidable EM signature. Now, what if that tank dares to even move an inch? Well, seismic sensors in the ground will feel the vibration from its tracks. And to top it all off, a trained dog might even pick up the chemical scent of materials on the crew. You see? The tank is screaming its location to our technology, even when it's trying to be completely silent. So let's step back and pull all of this together. What we've seen is that even the most carefully hidden targets just can't help but give themselves away through all sorts of physical and chemical signatures. And here's the whole thing in a nutshell. You've got EM energy, like heat, which you can pick up with a thermal camera. You have mechanical waves, like vibrations, that you can find with a seismic sensor.
And you've got chemical effects, like scents, that a detector or a dog can find. It's three totally different ways of finding the very same target.
Really, the big takeaway here is pretty simple. Nothing can stay hidden forever. Every target reveals itself through its unique signatures. And while that unavoidable heat signature is often your best and most reliable clue, when you start layering on mechanical and chemical detection, you create this dense net that makes it almost impossible for anything to go completely unnoticed. So the next time you think about something being hidden, I want you to think about this. Why is heat considered so unavoidable? And how does that one simple fact make something like thermal imaging so much more powerful than our own eyes? It really makes you wonder. In a world where we can see even the faintest heat from miles away, what does it even mean to be invisible anymore?